So here we have our rules of exponents for monomials. All of these rules are in Algebra 1 review, so let's go ahead and apply these rules to our examples in our video. So for our first example, on this one, now there are multiple ways of doing these problems. My theory is if you just stick with order of operation, it'll be consistent every time. So if order of operations, we start with our parentheses. We can't do anything inside of it, but we do have this exponent out here. Now we're going to distribute this exponent to every single base inside the parentheses. So we're just going to bring down their AB. Then we're going to have 2 to the negative 2, A to the negative 4 because we're multiplying, and B to the negative 8 times A to the negative 3. So now we pretty much have a multiplication. So always have your number out first because your number is going to be the coefficient of the monomial, so always start there. So 2 to the negative 2 is actually going to turn into a fraction, so we're going to have 1 over 4. And then we're going to multiply. So we have A to the negative 4, and A to the negative 3. And that's going to give us A to the negative 6 because we're going to add all the exponents. Now for our B, we have B to the first and B to the negative 8, so we have B to the negative 7. Now, we cannot have negative exponents, so what happens is both of these bases and their exponents are going to go down to the denominator. So in your numerator, you're going to have 1 all over the 4, because that's at 1/4 over here, and then A to the 6th, B to the 7th. Now, once when they move them, they turn positive. So this is our first answer. Now in the second one, once again, order of operation. So we can't do anything with the numerator at first, so we're just going to drop it down. And then in your denominator, we have that exponent out here. So once again, we're going to distribute this to each of the bases. And when you do that, you're going to multiply your exponents since you have power to a power. So negative 12, B negative 6. Now we're going ahead and divide. When you divide, you're going to subtract your exponent. So negative 2 minus a negative 12 is going to get you A to the 10th. Then 4 minus a negative 6 gives you B to the 10th. Now, since we can't combine these, we can't do anything else with them, this is your final answer as well. Our next one. Right here, we have this n to the 0. Anytime you have an exponent that's raised to the 0, automatically just cross it out because it equals 1. So if you just go ahead and get rid of it now, we won't have to deal with it anymore. So now let's go ahead and get rid of this parentheses here by distributing this as negative 1 just to the m here. So we're going to have m to the negative 1 times 2 n to the negative 1 all over 3m negative 3 and negative 3. Can't combine anything in the numerator or denominator, so let's go ahead and divide. Once again, focus on your coefficients first. So we're going to have 2 over 3. Then negative 1 minus a negative 3 is going to give us m squared. And then we have negative 1 minus a negative 3 gives us n squared as well. Now in this one, you could leave it like this, but I'd rather have you leave it as one whole fraction. So it'd be 2m squared n squared all over 3. So let's just combine that fraction together. Now our next one, we have this huge mess in here. So with order of operation, you want to start inside the parentheses. So what we're going to go ahead and do is clean up this stuff in here. So we're going to have, in our numerator, nothing can be changed yet. So we have 2c a negative 4 b negative 2. And on the bottom, we have this 2 out here. So we're going to say, now a negative 1, a3 is a squared. B and b3 is b to the 4th. And then c negative 2 and c negative 4 is c to the negative 6. Remember, when you multiply, you're going to add those exponents. Make sure as you condense this, you carry this exponent over. I don't want you guys to lose it in the transition of all this and then completely forget to raise it to that power. So now let's go ahead and clean up the inside of here. Well, those 2's go ahead and cancel out, so those are gone. Now, I'm just going to go alphabetical because to me it just makes more sense to just go A, B, C, D to have some kind of rhyme and reason with this. But if they're all different, kind of jumbled up, it's okay. I just usually just go alphabetical. So we have negative 4 minus 2 gives us a to the negative 6. And then b negative 2 minus 4 is going to give us b to the 6 as well. And then we have c minus c to the negative 6, so it gives us c to the 7th. And then this will be raised to the negative 2. So now this whole thing cleaned up to just these 3 variables right here. Then we have power to a power, so we're going to go back and distribute to each and every single one of these exponents. So we're going to have a to the 12th, b to the 12th, and c to the negative 14th. Now, this is not our final answer because we have this negative exponent, so you're going to have to bring it to the bottom of your denominator. So we're going to have a12, b12, all over c14. And this is our final answer. Now our last one. We're going to come back to this in chapter 10, but it does deal a little bit of exponents in here, so I want to sort of introduce it to you guys as well. Now, we want to solve for x. So this is saying, what does x equal here? Now, with our bases being exactly the same, all you have to do is just take these two exponents and set them equal to each other. So you're going to have x plus 3 is going to equal negative 3x. And all you have to do is just solve for x. So subtract x. So you have 3 equals negative 4x, and then divide by negative 4. So x is going to equal negative 3 over 4. Like I said, we're going to come back to this in chapter 10 when we have different bases and so forth, but for this instance, if you see this and they want you to solve for x, just set your two exponents equal to each other.